Hi guys, I hope that you're all doing well. In today's lesson, we'll learn prime numbers or prime factors in exponents. Let's try to solve 50 to the power x plus 1 times 45 to the power x. Normally in exponents, you have to consider your bases. You have to check whether you have the same base. In this case, you have 50 and 45. You don't have the same base. So when you have such huge numbers, you can try to break down these numbers by writing them in as a product of their prime factors. And to do so, you can just use your calculator. You have to punch in your number. Let's say 45 is equal to shift plus fact. Then you get your answer. Let's try 50. We have 50 is equal to shift fact. It gives us 2 times 5 squared. We've written 50 as a product of its prime factors. Now let's try with 45. We should get 45 is equal to shift fact 3 squared times 5. 45 can be written as 3 squared times 5. So let's try to solve this so that you guys can get familiar with the formula. Let's try 50. 50 and 45, you don't have the same base, so you can try to break down 50. 50 is equal to shift fact. You get 2 times 5 squared. You've written 50, which is your base, as a product of its prime factors. It's 2 times 5 squared. So you still have to account for your exponents. I've written this in a bracket so I can write my exponents there. So you have to write down our x plus 1 times, we can write down 45 as a product of its prime factors. Let's punch 45 in a calculator. 45 is equal to shift fact. We get 3 squared times 5. We've written 45 as a product of its prime factors. So we still have to account for the exponent. We write it there outside a bracket. We have x. So what's the next step? In mathematics, you guys know that you always try to simplify what's in the bracket first. So you have 2 times 5. Do you have the same base? No. So we can't apply any of the laws. If you had 2 times 2, you'd have two bases that are multiplied, so you just add the exponents. But it's impossible here as you don't have the same base. So our formula doesn't apply. Let's move to the second bracket. You have 3 and 5 as your base. You don't have the same base, therefore you cannot add the exponents. So what can we do? We can distribute this x plus 1 into every term that is inside the bracket. It'll be 2 to the power 1 times x plus 1. 2 times x plus 1. Now let's solve this. We have 2 as our base, which is basically 2 to the power 1 times, in a bracket, x plus 1. Times, we have 5 as our base, you write it as it is. It's 5 squared times x plus 1. Right? Then you have to move to 3 squared times 5, which is the second bracket. We have 3 squared, you write down a 3 squared, times x. Times, we have 5, which is basically 5 to the power 1, times x. Now let's multiply. We write down our base as it is. We have 2, 1 times x, which is x, 1 times 1, which is 1, positive 1. Times, we have 5, 2 times x, which is 2x, 2 times 1, which is 2. Times, we have 3 as our base, 2 times x, which is 2x, times 5, 1 times x is just x. Now let's check whether we have any similar bases. We have 2, we don't have another 2. We have 5 and 5. We have two bases that are multiplied, therefore we can add the exponents. We have 3, it's only 3, so we can try to solve 5 and 5. Let's do so. Let's write down 2 to the power x plus 1 as it is, times, we write down our base, which is 5. Right? 5 times 5, write down the base, then we add the exponents. You have 2x plus 2 plus x times 3 to the power 2x. Now let's solve. We write down our 2x plus 1 as it is, times 5. Now let's look for like terms. You have 2x plus 2 plus x. 2x and x are like terms. So 2x plus x is 3x. And just to recap, remember when you have a variable as it is, the coefficient is always 1. There's an invisible 1. So it's basically 2 plus 1, which is 3. Now you write down your x. We're left with plus 2 times 3 to the power 2x. So your final answer is 2 to the power x plus 1 times 5 to the power 3x plus 2 times 3 to the power 2x. This is your final answer. And that is how we work with prime factors in grade 10. Now let's do 2 more examples. Let's move to number 2. We have 12 to the power x plus 2 times 18 to the power x minus 1. What should we do? We have to firstly check whether we have the same base. We have 12 and 18. We don't have the same base, so we can't apply any of our exponents. We have 12 and 18. The two terms are multiplied, however, it's not the same base. So we can try to break down 12 and 18 and write them as a product of the prime numbers. So you have to go to your calculator and punch 12 is equal to shift fact. You have 2 squared times 3. We have to account for our exponents, which is x plus 2 times, let's punch 18 in a calculator. 18 is equal to shift fact. We have 2 times 3 squared. Let's not forget our exponents. You have this should be x minus 1. What's the next step? You have to check whether we have any similar bases in the bracket. You have 2 and 3, not the same base. 2 and 3, not the same base. So we can try to distribute the x plus 2 into the different terms in the bracket. So firstly, we have 2 squared times x plus 2 times 3, which is basically 3 times 1 times x plus 2, times we have 2, which is basically 2 to the power 1 times x minus 1, then 3 squared times x minus 1. Now let's solve. We have 2 as our base, 2 times x, which is 2x, 2 times 2, which is 4, times 3, 1 times x is x, 1 times 2 is positive 2, times 2, 1 times x is x, 1 times minus 1 is minus 1. So it's 1 times minus 1 is negative 1. So this should be x minus 1 times 3. 2 times x is 2x. 2 times minus 1 is negative 2. So let's check whether we have any similar bases. We have 2 and 2, 3 and 3. So we do have similar bases. Now let's check whether we have any similar bases. We have 2 and 2, 3 and 3. We do have similar bases. So let's start with the 2's. We have 2 and 2 here. We have 2 bases that are multiplied, so we add the exponents. So you write down a basis, it is 2, then 2x plus 4 plus x minus 1 times, we have 3 and 3. We have 2 bases that are multiplied, so we add the exponents. So you write down our base, which is 3, then x plus 2 plus 2x minus 2. Now let's simplify. We have 2. Let's look at our exponents and identify like terms. 2x plus x. Those are like terms, which is basically 1x. So 2 plus 1 is 3. We have to write down a variable. Plus 4 minus 1, which is positive 4 minus 1. It's positive 3. Times, let's move to 3. You write down our basis, it is, let's look for like terms in the exponents. You have x plus 2x, which is basically 1x plus 2x. 1 plus 2 is 3. You have to write down a variable, then 2 minus 2, which is 0. So your final answer is 2 to the power 3x plus 3 times 3 to the power 3x. Now let's do an example that includes solving them in a fraction. This video is proudly brought to you by McDonald's. Download the McDonald's app today and start earning points every time you order your favorite meals. The more points you collect, the closer you get to exciting rewards like free burgers, desserts, drinks, and more. Simply order through the app, collect points, and redeem them for delicious treats once you've reached the required threshold. Get the McDonald's app now for more information and start enjoying rewards with every bite. Now let's try to solve 27 to the power x plus 2 times 8 to the power x minus 1 all over 9x times 12 to the power x minus 1. How do we solve this? Let's check whether we have any similar bases. You have 27 and 8, those aren't similar. 9 and 12, we don't have any similar bases. So when we're stuck, we can try to introduce these numbers as a product of their prime numbers. Let's start with 27. We have to punch 27 in a calculator is equal to shift fact. You get 3 squared. 3 cubed. So this is 3 cubed in a bracket. Let's account for this x plus 2. Times 8. Can 8 be written down as a product of its prime factors? Let's check. 8 is equal to shift fact. We get 2 cubed. Let's account for the x plus 1. X minus 1. Guys, sometimes when you have numbers like, let's say 5 can be written as a product of its prime factors. Let's try 5 is equal to shift fact. It's just 5. So if you try to break down a number and you don't get an answer, then it can be broken down. Let's move to the denominator. We have 9x, and 9 can also be written as a product of its prime factors. We get 3 squared. Let's account for the exponent. We have x times 12. Let's break down 12. 12 is equal to shift fact. We get 2 squared times 3. Let's account for the exponent. We have x minus 1. So what can we do? Let's try to simplify in the bracket first. We have 3. We can't really do much in that bracket. We have 2. We can't do anything there. We have 3. We have 2 times 3. Are they common? No. So we can't look at these terms and add the exponents, as 2 and 3 are not similar. So let's try to distribute this x plus 2 into the bracket, x minus 1 into the bracket, x into the bracket, x minus 1 into the bracket, x minus 1 into 3. Let's start with 3. We write down a basis, it is 3. Then we have 3 times x, which is 3x. Then 3 times 2, which is 6, times, we write down our base, which is 2. 3 times x, we have 3x. 3 times minus 1, you should have negative 3. That's your numerator. Let's move to the denominator. We have 3 as our base. 2 times x, which is 2x, times 2. You write down our base as it is 2 times x minus 1, right? 2 times x, which is 2x. 2 times minus 1 is minus 2. Now let's verify, since I've been writing down all the steps. This is basically 2 times x minus 1, right? 2 times x is 2x. 2 times minus 1 is minus 2. So you should get 2x minus 2. It's similar to that one. So we didn't make any mistakes. Let's move to 3. We have 3, which is basically 3 to the power 1. So 1 times x is just x. 1 times minus 1 is minus 1. Let's try this on the side. 1 times x minus 1. 1 times x is x. 1 times minus 1 is negative 1. So we do have x minus 1 there. Now what can we do? Let's check whether we have any similar bases in the numerator and the denominator so that we can simplify. We have 3 and 2. Those aren't similar. We have 3 and 3. We only have 2 there. So you can try to simplify those. Let's write the numerator as it is. 3 to the power 3x plus 6 times 2 to the power 3x minus 3. Can you guys see that I'm being patient? I'm not rushing to get the final answer. Over, we have 3 and 3. So you write down a base, which is 3. You have 2 bases that are multiplied, so we add the exponents. You write down a base, which is 3, then 2x plus x minus 1. You write down the 2 as it is, times 2 to the power 2x minus 2. Let's simplify this. We have 2x plus x, which is 3x. 3 to the power 3x plus 6 times 2 to the power 3x minus 3, all over 3 to the power 3x minus 1 times 2 to the power 2x minus 2. Now what should we do here? We have 3 and 2, 3 and 2. We can't really do anything in the numerator and the denominator. However, we can divide these terms as they are. Why? Because we have 3 and 3. We have 2 terms that are divided. We also have 2 and 2 there, so we can divide these terms and subtract our exponents. So we can write this on the side. Let's start with this part by writing it on the side because I know that fractions can look intimidating. We can write this on the side. Let's start with 3 and 3. We'll have 3 to the power 3x plus 6 divided by 3 to the power 3x minus 1. You have the same base and they're divided, so you subtract their exponents. We should have 3 to the power 3x plus 6 divided by, minus, in a bracket, 3x minus 1. So how do we solve this? Let me write this here. We have 3x plus 6 minus 3x minus 1. We're solving the exponents. So this is basically minus 1 here, right outside the bracket. So you write down the 3x plus 6 as it is. Then minus 1 times 3x should give you minus 3x. Minus 1 times minus 1 should give you a positive 1. Now let's look for like terms. We have 3x minus 3x, which is 0. They cancel each other out. Then 6 plus 1, which is 7. So you're left with 7 there. Let's show our method here. We have 3 to the power 3x plus 6 minus 3x minus 1 times, let's move to 2. You have two bases that are divided, therefore we subtract the exponents. Let's write this on the side as well. We have 2 to the power 3x minus 3 divided by 2 to the power 2x minus 2. Okay, so we'll say 2 to the power 3x minus 3 minus 2x minus 2. Let's solve this as well. 3x minus 3 minus 2x minus 2. You know that there's a 1 here, so there should be 3x minus 3. You have minus 1 times positive 2, which is minus 2. Don't forget the x. Minus 1 times minus 2, positive 2. You have 3x minus 2x, which is basically 3 minus 2, which is 1. So you just have x there, then minus 3 plus 2, which is minus 1. So we should have x minus 1 as a numerator. Let's write this here. You write down our base, which is 3x minus 3. Our base, which is 2, then 3x minus 3. Minus, we have 2x minus 2 in a bracket. So we should have 3. Here we have 3x plus 6 minus 3x plus 1. So we can take this step by step as well. We have 3x plus 6 minus 1 times positive 3 should give you negative 3x. Then minus 1 times minus 1 should give you a positive 1. Times you have 2 to the power 3x minus 3. You have a minus 1 there. Minus 1 times positive 2 should give you a minus 2. Don't forget the x. Then minus 1 times minus 2 should give you a positive 2. Let's calculate. Let's start with 3. 3x minus 3x, they cancel each other out. It's 0. Then 6 plus 1 is 7. Times 2, we have 3x minus 2x, which is basically 3 minus 2. It's 1. Don't forget the x. So we have x minus 3 plus 2 should give you a minus 1. And this is your answer. 3 to the power 7 times 2 to the power x minus 1. And that is how we deal with prime factors in grade 10, prime numbers. If you have any questions, feel free to comment. I'll see you guys in the next lesson. Thank you for watching. Please like and subscribe.